Hello, today we're going to cover section 7.1, properties of exponents. Objectives. Recognize and apply the null and identity properties of exponents. Recognize and apply the same base law. Recognize and apply the same power law. Recognize and apply the power of a power law. Simplify expressions using the property of exponents. Part 1, exponents. You can think of exponents as repeated multiplication. For example, 2 to the 5th power can be thought of as repeatedly multiplying 2 by itself 5 times, or 2 times 2 times 2 times 2 times 2. The number which is being repeatedly multiplied is called the base. The number indicating the number of repeats is called the exponent. In the previous example, 2 is the base and 5 is the exponent. Consider the expression 5 to the 4th. Write it as multiplication. 5 times 5 times 5 times 5 with 4 5s. What is the base? 5. And what is the exponent? 4. Consider the expression x cubed. Write as multiplication. X times x times x. What is the base? X. And what is the exponent? 3. Part 2, unpacking exponents. Complete the following table using the idea of repeated multiplication. Then in the final row, use the pattern to write the exponent rule in general. The first one is done for you. So for example, 2 to the 3rd power times 2 to the 4th is 2 times 2 times 2 times 2 times 2 times 2 times 2. Notice that there's 7 2's all in together, so 2 to the 3rd times 2 to the 4th is the same thing as 2 to the 7th. So if we repeat this, we get 3 times 3 times 3 times 3 times 3. Well, now that there's 5 3's, that's 3 to the 5th power. Or 5 to the 4th times 5 to the 5th, well, that's 5 times 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 5. So after expanding it out, we see there's a total of 9 5's, so we get 5 to the 9th power. One more example, 7 to the 2nd power times 7 to the 6th. So that's 7 times 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 7. So we get 2 7's, 6 7's. Altogether then there's 8 7's, so this is 7 to the 8th power. So I'm hoping you notice the pattern that in general, x to the m times x to the n is x to the m plus n. Does this rule work for 4 to the 3rd power times 5 to the 2nd power? Explain. If so, what is the result? If not, why not? So this rule does not work because if we were to expand it out, it would be 4 times 4 times 4 times 5 times 5. Well, now these are not the same number, so I cannot rewrite it as a single exponent together. So since the bases are not the same, we cannot rewrite it as a single exponential expression. What might be a good name for this rule? A lot of textbooks call this the product rule, because you are taking the product of two exponents. I like to be a little bit more specific. The product rule of same bases. Okay, let's move on. Complete the table using the idea of repeated multiplication. So same as before. And you can see with the first one, we have 3 to the 5th over 3 to the 3rd. So you get 3 times 3 times 3 times 3 times 3 over 3 times 3 times 3. So the 3's on the bottom cancel out the 3's on the top, and you're left with 3 squared. So what if we have 6 to the 6th over 6 cubed? So that's 6 times 6 times 6 times 6 times 6 times 6 all over 6 times 6 times 6. And again, we're going to get 3 6's on top, cancel out with the 3 6's on the bottom. So we're left with 3 6's on top, so that's 6 cubed. 5 squared over 5 to the 1st. So 5 times 5 over 5. Well, we get 1 5 that cancels out on top and bottom. So then we get 5 to the 1st power, which of course is just 5. Now, 8 to the 10th over 8 to the 5th. Well, this is 8 times 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 8. Did I get enough? Yes, I did. Over 8 times 8 times 8 times 8 times 8. Well, of course, the 5 8's on the bottom cancel out with 5 8's on top. And then we're left with a total of 5 8's on the top. So our final answer is 8 to the 5th. So if we have x to the m power over x to the n power, I'm hoping you're noticing that in this scenario, we subtract the exponents. So we get x to the m minus n. Does this rule apply or work for 4 to the 2nd over 4 to the 2nd? Explain. If so, what is the result? If not, why not? Well, let's try it. So 4 to the 2nd is 4 times 4 over 4 times 4. So then all the 4's cancel out. So we get 1 because, and that makes sense because anything divided by itself should equal 1. Well, does that equal 4 to the 2 minus 2 power, which is 4 to the 0? Are these equal? And actually, that is the definition of raising a number to the 0 power. And this is the reason why anything raised to the 0 power equals 1. So this is, yes, it does work. So if you didn't know that already, it's something I would note down. Any non-zero number to the 0 power is 1. And what might be a good name for this rule? So going off the first rule we did, we're going to just call this quotient rule for same bases. Forgot the word rule. Okay, let's move on to the next one. So here, we're thinking of like 3 squared to the 3rd power. So 3 squared is 3 times 3. But then we have that to the third power, which is 3 times 3 times 3 times 3 times 3 times 3, which gives us 3 to the 6th power. I'm actually going to think of the next one a little bit differently when we do it. So 4 to the third power in parentheses to the 4th power. I'm actually going to consider the 4th power first. So this would be 4 to the third times 4 to the third times 4 to the third times 4 to the third. Now from the product rule for same bases, because these all have the same base, I know this will equal 4 to the 3 plus 3 plus 3 plus 3. So then this is 4 to the 12th power. Now we have 2 to the third power, 2 to the third power. So using my method again, that's 2 to the third times 2 to the third times 2 to the third, which again, because these all have the same bases, we add the exponents. So this is 2 to the 3 plus 3 plus 3, which is 2 to the 9th power. Then we have 2 to the 4th to the 2nd power. So that's 2 to the 4th times 2 to the 4th, which is 2 to the 4 plus 4, which is 2 to the 8th power. And then we have 8 cubed to the 1st power, so that means we have 8 cubed once, so that means we have 8 cubed. I'm hoping you can see the relationship between the starting exponents and the ending exponents. And using my method, you can see why we multiply them. Because using the product rule, we get repeated addition. And repeated addition is defined as multiplication. So if we have x to the m to the n, this is x to the m times n power. Does this rule work for 3 squared to the 5th? If so, what is the result? Well, yes, it does work. Because we have a power to a power. So in this case, the result is 3 squared to the 5th, which is 3 to the 10th power. And what might be a good name for this rule? Well, it's the power to a power rule. And that's it for part 1 of section 7.1.